Welcome to the latest installment of Blue Marble GeoTalks. Today's topic is what's new in Geographic Calculator 2023 Service Pack 1 or SP1. My name is Scott Weber. I'm a product manager, and I'm here today with Sam Knight, the Director of Product Management.
Good morning, Scott. Good morning, everyone. So the format of today's webinar is everybody is in listen-only mode. If you would like to submit a question, you should see a questions panel attached to the controls, usually on the right side of your screen. We will save some time for questions at the end of the session, but we also usually try to take the ones related to what we're talking about at the moment right in line if we can. So feel free to throw a question in that box at any time. And also the session today is being recorded, and we will have that processed and posted on our YouTube channel and website in just a few days' time.
And as we get started, let's look at a couple of informational things that may be useful to you, like upcoming webinars. After the holidays, we have what's new in Global Mapper version 25.1 standard on February 21st. And then the following week, the Pro version of 25.1 on the 28th. And then the top 10 tips in Global Mapper Pro on March 20th. And for more information on that, you can go to bluemarblegeo.com and then GeoTalks Express webinars.
Yeah, good topics coming up there. The Global Mapper Pro tips and tricks is always a very popular session. Okay, and beyond our usual webinars, so we refer to our monthly webinars like this as GeoTalks Express, and that comes from our full day-long online conference that we call GeoTalks. So coming up in 2024, this is a conference, it's a one-day conference that will take place on January 24th, and it is a full day online. So we have a variety of speakers on all different topics related to all of the things we do here at Blue Marble Geographics. So we'll have some topics that relate more on the global mapper side. We'll have some topics that relate more on the geographic calculator side. All of the SDK users and all of those sorts of things. There's a little bit something for everybody. We have the agenda for the day is in its final stages of planning. And it's actually going to be published on our website, I believe in about a week's time.
December 8th.
I'm sorry, December, excuse me, not in a week's time. It's going to be published online and will go out. If you've attended previously, you'll get some emails talking about what all the agenda is. There's some speakers that I'm particularly excited to hear myself, so it should be a very good day for everyone.
Thanks, Sam. Now we also have some upcoming training. We have online training sessions, live online training sessions, Global Mapper the week of November 27th, and then the following week, LiDAR processing training. And then we have a fairly new introductory self-training available at training.bluemarblegeo.com. And currently there are basic introductory courses in Global Mapper and Geographic Calculator, but we're developing more, so stay tuned to that.
Okay, and lastly, before we actually get into it, our reminder on our annual academic scholarships. So here at Blue Marble, we offer a chance to win a $1,000 scholarship and a copy of Global Mapper Pro. This is open to any undergraduate students. The detail here is that it does need to be at an accredited institution of higher education. So either undergraduates or graduate students are eligible for that, as long as you're at an accredited school. The full details of that scholarship entry are at our website. You'll see the URL there on the screen, but you can also get into that you can find it under the menus on the website as well. The submission deadline for that is December 31st, so don't delay if you are an interested student in getting into that program.
Okay, and the agenda for today, we're going to look at the LAS LiDAR format support in Global Mapper 2023 SP1. And we also have a 4-parameter Helmert method added to the point database Bestfit Job. We have 3 new transformation methods that we want to talk about. the Similarity transformation, the Canadian BYN format transformations, and the New Zealand deformation models. And at the end, we'll just take a quick look at how to upgrade to Calculator 2023 SP1. Okay, so if you're new to Calculator, the Geographic Calculator, when you bring it up, you will see a job guide, and it gives you some basic information on how to navigate the program. On the left-hand side of the job guide, you see a list of all the 13 different what we call jobs that do various functions. And we also have some tools like the georeferencer and some unit converters. And the start page is a tab, and we also have a viewer tab, and we can load data into the viewer. And just by example, I'll take just a second here. I'm going to load a LAS LiDAR file that we're going to look at in just a moment. I apologize, I meant to have this loaded already. And there we go. And this is Portland, Maine. It's a fairly large LiDAR file. And then if we go to the vector data conversion job, which is where we would process a LiDAR file, whether it be LAS or LAS. Calculator has processed LAS files, LAS, for quite some time, but the LAS processing capability is new. And we can see in the vector job, it will load with the coordinate system that's indicated in the LAS file. And in this case, it's a version 1.1 file. And so the coordinate system information is in the form of geotiff tags. And then in this example, we're just going to change the coordinate system. This is a file from 2006, and we're going to update the target to NAD83 2011 from just NAD83, and it's in the Maine West state plane coordinate system. And we can also update the geoid. We could stay on NAVD88, but convert from, say, geoid 2012B to 2018. Now let's just take a quick look at how that works. So the horizontal transformation, we can use the NGS NADCON5 transformation. And that is a set of concatenated transformations that step through each of the realizations of NAD83. We'll see that in a moment. And then we can select a geoid model, like 2012B and 2018. So here you can see the concatenation of 4 NAD83 realizations from the original 1986 all the way stepping through to 2011. And then while we're staying on NAVD88, we're actually changing the geoid from 2000, in this case, 2018 to 12B. I should have selected the reverse going from 12B to 18, but that'll suffice for our example here. And then we could process that. And I'm not going to go through that step here. We'll do it like a cooking show and just imagine that when we're done, we would see this file, but with converted horizontal and vertical coordinates.
So Scott, on the LAZ format, there are probably some folks who may not be familiar with the differences between LAS and LAZ. And it's often confusing for many folks when they hear us talking about it, LAS and LAZ, because they sound so similar. They really are intended to be compatible formats with each other. They store all the same information. So what's the real difference there? And it's actually in the Z. The Z implies a zip type compression. So LAZ is simply a compressed way of storing LAS data that can be very large. There are millions and millions of points in these files, and the LAZ format allows us to deal with the compressed flavor of that. So in the case of this file that we have here, the file itself is about 250 megabytes, if I remember. And uncompressed, if this were an LAS file, that would take up much closer to about a gigabyte.
Thanks for bringing that up, Sam. And one other thing that I can mention here is that this LAS file is in version 1.1 with the geotiff tags, and Calculator does give you the option to change that version number. So under Options, Preferences, Vector Processing, we can upgrade the last LAS version. The default is the same as the source. But if I go in here and select 1.4, then when I process this job, the output will be in LAS version 1.4, LAS version 1.4. And the difference there is that the coordinate system information is stored as a WKT form of parameters rather than geotiff tags. Okay, moving on. The next one is the new method in the point database Bestfit Job. So here is a Bestfit Job. It works with a spreadsheet of numbers that consist of a local or survey grid of northings and eastings, and these are control points. So we also have known coordinates, in this case in WGS84 UTM zone 15 north. And so the Bestfit Job will fit this local coordinate system to the WGS84 and create a new coordinate system, a fitted coordinate system, that will then allow us to process any data that is in this local surveying system and convert it to out of that local system into known systems through the WGS84 that we're specifying here. So we simply set the source coordinate system to what we know is the known, which are the second pair of columns. I've given it a name, Bestfit Helmert 4P, because this is the new method, and I'll just show you the list. Previously, we had affine and then second through fifth order polynomials available. But in response to user requests, we have added the 4-parameter Helmert. And what that is this is working in a projected space, a 2D plane of coordinates. And what it does is it will scale, apply a universal scale factor in both X and Y. And then it can rotate that plane and then finally apply a translation in X and Y, individual translations in X and Y. It's really a sort of a special case of affine where you're limiting what parameters you're allowing to vary here. But requested many times, and so we have added it to this job. And once I set my columns, I'm going to go ahead and process this because I need this output for the next example. And you'll see that we get some errors around that. We also can look at a plot of the errors. If we found that one control point seemed to be an outlier that we didn't want to use, we can go back and uncheck one of these boxes. There we go. So now in my data source, if I go to coordinate system definitions, under fitted, I will see that Bestfit Helmert 4P that I created. And so I can now use that in subsequent jobs. And so let's go ahead and do that. In the point database conversion job, I simply loaded that same control data. And what we're going to do is now select as a source that fitted system that we created. And let's take a look at the parameters of that while we're here. And we can see that indeed it has a single scale factor, X and Y translations, and the rotation. So I'm going to select that as my source. And therefore, if I apply that to my local northings and eastings that I've set here, and then if I want to go out to WGS84, zone 15 north, I've added a couple of columns here, and I'm going to preview that. And you can see that these output northings and eastings almost match my control point data. They won't match exactly because this is a fitted system, and that's why we saw that error plot showing what the errors would be at those control points. But they're very close.
So Scott, maybe before we move on, I see a couple questions coming in here. If you could go back to the Bestfit job for just a moment. Sorry, where we set up the fit. Yeah. So on the Bestfit job, the first question we had coming in was, I think we have someone here that is used to our older versions that we didn't have the checkbox column where we used to have the old binary setting of a 1 and a 0. And they're just asking about the checkbox. So the checkbox is for what we call the use flag. If you see down under the lower left there, you'll see the use flag, and it's set to column C5. We didn't give that one a very graceful name there. And the simple answer is yes, that has been replaced in 2023, I believe is where we stuck that in.
The checkboxes came in 2023, yes.
And so now it's a little more obvious to most folks what those do. Previously, those had been if there was a 0 in that column, it took it out of the model, and if there was a 1 in that column, it would use that in the model. We have wanted a checkbox in there for a long time. We finally stuck it in there last year. And then the second question coming in is, are we able to reorder the columns there? The question is specifically in the error plot, but really any of these columns. And the simple answer to that is yes. So they're drag and drop, just like any of the other columns. One of the most powerful things in any of the point database jobs is the flexibility in which the data can come in. In this case, we start off with a mostly blank sheet, and we add in those columns for the east error, north error, and then the reverse north and east errors as well. Scott actually created those before we started here. Typically, we would start with 4 columns, maybe 5 if you have a column of names or something like that for your survey marks. So you might have a point ID and then local northings, local eastings, and your control coordinates in northings and eastings or lat long, whatever you've got in there. And then part of the process for this in the basic operation of this job is the C5 through the error plots. Those can all be changed. Follow-up question coming in. Can you reorder the values in the columns? So I think he's asking maybe can we sort by the error? And that unfortunately is no. What some folks might do is this can simply be written out as a spreadsheet. We don't have a lot of control in this tool for reordering columns in any of the tables that we work with. So if you are working with maybe a lot of points and you want to see them ranked, you might want to look at writing out that sheet as like an Excel sheet or maybe ODS or something, whatever type of spreadsheet operation you're going to use. And then you'd want to use in those tools. This is outside of ours again. You'd use a multi-column sort, so maybe sort them by the east error and then a subsequent sort by the north error to put them all to the top. Sorting is something that we've considered over the years, but typically the calculator is more based on faithfully reading in and out the coordinates that we've got rather than manipulating the row order and such.
Thanks, Sam. Traditionally in the past, if you wanted to work with this particular transformation that we used in this method, the Helmert 4 parameter, there were a couple of ways to work with those. So if you were given a data sheet with the transformation parameters in that form, we do have a job called scale and translate, point database scale and translate. And here I've loaded that control data again. And you'll notice that here I've selected Helmert 4 parameter as my operation type. And that would be the same method of scale a single rotation around the z-axis or normal to the projection plane, and then translations. So this is a manual process where you would have to type in these numbers. You could save this job and reuse it, but there was no way to permanently add these parameters to what we call the data source or our database of transformations. So that has changed. So moving on to new transformation methods, the first one we'll look at is the similarity transformation. Now, the similarity transformation happens to be one and the same with the Helmert 4 parameter, two different names for the exact same set of parameters. We've called it the similarity transformation because we followed the EPSG model for this, and that is the name that they use there, and it is a very common name for this transformation as well. So a little point of confusion there, but they are one and the same. So let's take a look. Let's assume that you were given a data sheet with the transformations from this best fit job. So here's your local coordinates, and here is a best fit to get to WGS 84, zone 15 north. Now I can go into my data source, coordinate transformation definitions, and this would be a parametric transformation. And I've already set one up here, and we'll take a look at it. And so I've called it local transverse Mercator to WGS 84 UTM zone 15 north. And you can see the type is similarity transformation. And if we view the info on that, you can see that it again has the same 4 parameters, a little bit different names, again following the EPSG convention, but a rotation, scale factor, and an X and a Y translation. So I've created this transformation based on this local system going to WGS 84. And this is now stored as a custom coordinate system in my data source. So I can use it again and again and again simply by pulling it up. So let's look at an example of that. So in this using the similarity transformation job, I've loaded these same data, set my local TM coordinate system as the source, WGS 84 15 north is the target, and I've created a couple output columns, and then all I need to do is select that similarity transformation. I double click to select it, by the way, and I can preview that. And if we compare these output numbers to the output numbers from either our manual Helmert, which I didn't preview, but I will do that now. Those are the same exact values. And we'll also see that if we were to go back to our original coordinates, they are close, but not exact because it is based on a fitted system. The next new transformation method we'll look at involves the Canadian NRCan, Natural Resources Canada, BYN format. And there are a couple of different methods that use this format, and we'll look at 2 of them, the geoid model and the vertical offset. So in this particular job, I've selected a point that's somewhere in Canada, 55 degrees north, minus 100 degrees or 100 degrees west, and I've selected an arbitrary height of 200 meters. And I've selected a source and target coordinate system of NAD83 CSRS V7. So that's a typical Canadian NAD83 base system. And I've selected ellipsoidal height on my source side and the CGVD 2013A 2010 epoch vertical coordinate system for the target. So this would be a geoid model transformation going from ellipsoidal height to the vertical datum. And if I pull up my transformation methods. There's no horizontal transformation here because I have NAT83 CSRSV7 on both sides. And if I go to Canada, I see, move this over a little bit, a transformation from NAT83 CSRSV7 to that's the ellipsoidal height in that horizontal datum. And I'm going to go to the vertical that I mentioned. And we notice the type is, it's called, this is the EPSG name for it, Geographic 3D to Gravity Related Height. And it's basically a geoid model. So let's note the change that we get here. So the ellipsoidal height becomes 232 of 200 becomes 232.23 in CGVD 2013A 2010 epoch. Now, they've also created some handy vertical offsets. So you may already have your data converted from ellipsoidal height to the older CGVD 28 vertical coordinate system. And if so, we can start with this vertical. So now my source, it's the same horizontal system for source and target, but I've now got the CGVD 28 height for the source vertical. And that would work out if I had used the older geoid model that's available to go from ellipsoidal height to CGVD 28 height, you would get 232.38 meters. Now I can go directly from the older CGVD 28 to the newer CGVD 2013A, it's a mouthful, 2010 height, using the other bin format method. And here we have what's called a vertical offset by grid interpolation, also using the bin format. And this allows me to go directly between the two different vertical coordinate systems. And if we do this, we should get the same result as we got in the first job, going directly from ellipsoidal height to CGVD 2013A 2010. And it was 232.23. If I go back to the previous one, I also have 232.23. So this gives you some flexibility depending on the data that you're given, whether it's ellipsoidal heights or whether you have data already in CGVD 28. You don't have to do a two-step process and take CGVD 28 back to ellipsoidal height to get it into the newer vertical datum. So we've added those. And finally, we have the New Zealand deformation models that have been added. These are a time-dependent transformation, obviously for New Zealand, and they go from ITRF 1996 to the New Zealand geodetic datum of 2000, NZGD 2000. And I've got ellipsoidal height for both sides here, and I have to enter a date. So, and the date has to be the same on both sides. And I've just entered January 1st of 2013, somewhat arbitrarily. I've selected a point in New Zealand. I've used an arbitrary height of 200 meters again. And when I click on my transformation box, I see that there are 7 choices. And the way this works is that they're ordered by version number. So 1 is the oldest version and 7 is the newest version. So if you go to the Land Information New Zealand website, you'll see that they have these different versions of the deformation model that they've developed over time. If you use their online calculator, you'll only see the latest version available. There are some other tools that you can use to get the older versions. But we have implemented all of the versions so that you can match up to older data as needed. So let's start by selecting the newest model, And I can see the version of that by viewing the info, and there's a version parameter in the details. So this one is 2018, July 1st. So that's the most recent one that's out there. And I can select this. Now this is a horizontal transformation, but it's three-dimensional. So we're going to see changes in both horizontal and vertical. So when I calculate, you can see that they're quite small, but there are changes based on the active tectonic motions that are going on in New Zealand, both horizontal and vertical changes. But maybe you are trying to use an older version, and that is also available. So this one, version number 6, is from 2017. So it's a year earlier, roughly about 6 months earlier, actually. And if we watch over here on the right coordinate point, we will see that it changes. So 7 different versions of the New Zealand deformation model are now available for use.
So that's a pretty interesting transformation in the geodetics industry, just because there aren't too many models that are actually factoring in those time-based changes in heights. It's a fairly new thing in geodetics. There have been many different older ways that people have gotten near that, but typically the accuracy that we've been working at in the verticals is much fuzzier than the level that these are actually transforming to. So these, while it looks like there's not a whole lot of change going on there, if there's a measurable change in 6 months and LINS is actually publishing the data to model that, that's a pretty fascinating development to me.
And speaking of time-dependent transformations, Geographic Calculator is fully capable of handling time-dependent transformations in general. There are many methods of time-dependent transformation, whether they be the 14 parameter or some of the Canadian velocity models. And as we move into the new NatRef 22 US datum, time is going to be ever present and part of the coordinate, and we are ready to work in that domain. So a lot of changes coming down the road. NatRef 2022 isn't scheduled to actually come out until 2025, but we will be ready to work with those new time-based coordinates. Any other thoughts on that, Sam?
Let's see. Why don't we maybe we'll come back to that. I think we have a couple of questions coming up. Why don't we get through the next steps? We can come back to some of those questions in the end, because we might pop around the interface a little bit first.
Okay. So how to upgrade to Calculator 2023 SP1. Just want to go over this briefly. You can download from the website shown there. And again, this is being recorded, so you can refer back to it. But what I want to point out was when you install Calculator or upgrade Calculator, there's an option in the installer to either keep or replace your existing files. And specifically, I mean the workspace file, the settings file, and that data source that contains all the coordinate systems and transformation objects and so on. So if you've been working in Calculator and have existing workspace that's customized, if you have particular settings that you've changed, and if you've created custom objects such as that Bestfit coordinate system or the Similarity transformation, I don't necessarily want to lose those. And so when you upgrade, you would select the keep option, and that would, there's actually 2 things, because it will give you an archive option, and it'll just package up all your old files for safekeeping. and then it will keep those files. What you will get is a new data source, a new updated data source with all the new coordinate systems and transformations that have been added since your latest version and so on. So there's some safety measures built in there that we've added in the last few years that make it safer and easier to upgrade. Now, then you need to license, and you can license with your current order number, dongle, network license. And if you have any questions about that, you can contact orders@bluemarblgeo.com and they'll help you out. Okay, so are there questions that we want to?
Okay, yeah, I see we've got a variety of questions coming in from some folks, so let's maybe head back to the calculator interface itself. The first question, this must be a new user. Can the calculator convert a batch of coordinates in a one-time process?
Yes, so assuming you mean a batch of files of similar nature, in other words, they have the same coordinate systems that you, both the source and what you want as a target, and the columns are in the same arrangement. The data are in the same format. So if you have degrees, minutes, seconds, they would all need to be in degrees, minutes, seconds, and so on. What we could do, I can give you sort of a quick example here. If we go to this point database conversion job, I have this job already set up to do a certain thing. I'm going to right click on that job and batch add. And this brings up a generate dialog, and you'll notice that it's all disabled, grayed out. And that's because I'm creating the batch from what we call a template job now, where it assumes that I want to use all the parameters that I've already filled in here. So my source is going to be the best fit. My target is going to be the WGS 84 zone 15 north. My columns are going to be as they were set in the template job. So all I really need to do here is add some data. And I'm just going to add one file here because that's all I happen to have handy. I think we do have a batch folder, but not prepared to set that up.
That's totally different settings.
Yeah,
exactly.
Exactly.
Probably a safer example.
So let's just do this for now. I can add like a suffix to make sure that I don't confuse my input and output. I could change format from, this happens to be an XLS file. I could change it to CSV, for example, by changing the format here. But let's just stick with the Excel format. And then I simply need to give it a folder location for the output. And I'm just going to say C10. Click the generate button. And now I've created what we call a batch node. And it's got the name of the, it's a point database conversion job because that was what kind of job was the input. And we have just one job in the batch because we only added one file. But if we had 15 files and added them all in that generate dialog, 15 jobs would be generated. And then when I want to run them, I click on the batch node, right click, and process. And it would process all 15 jobs without any further user input.
And so that's one way. Just to clarify, we often get this question of can we batch convert? And some folks mean just within one file, like within a table itself. And so in this case, what Scott had just loaded was an Excel sheet that has rows of many points in one single table. And that's what the point database conversion job is. That's sort of the main workhorse of the application. So whether you're talking about just batches of coordinates that are rows in a single table, or if you're talking about multiple tables, multiple files, that would be the batch process that Scott just ran through here. And that's actually true for all of the different types of jobs. So anything can be batched, whether it's a point database file, whether it's vector files or raster files. They all have these similar batch add process where you There's sort of two ways you can go through it, and one is what Scott just showed, where you do one job and make sure everything works. This is sort of what we call the best practice for this. You set it up, you test it, you make sure the settings all are good for your data, and then you right click on that, batch add, and copy all of those settings. The other way is you can simply create an empty batch node in the list and manually add things to it. When you manually add jobs within there, they will all run sequentially once the whole batch is fired off, and you have full control over all of the various settings that you've applied to those, regardless of whatever kind of data it is. So it is a very flexible interface. Some of those are the kinds of things you can get into in the introductory training sets that we have available, or in our classroom training as well.
I'm showing now the alternate, as Sam described, if I created a batch node directly, and then I'll just add that same file. But now you'll see that all the options are active, and I would have to manually set the coordinate system here. It would then apply to every job in the batch, but I'm setting it up directly. I won't go through the whole process, but here I have to set the target, set the source, set the columns, etc. So this is an alternate way to do it if you don't already have a template job and choose to do it this way. The nice thing about the template job is you can run that in advance and know that you've set everything correctly and that it works. And so that's the advantage of doing it that way.
Okay, let's see. Scott, I see kind of a long question here. Could you drag that window open just a little bit bigger so I can see the whole question? There we go. Maybe drag. Yeah, there we go. Well, I'm gonna read the whole thing on the fly and see if we can answer it. So, in Italy, we officially use paid grids, not NTV2, from the Istituto Geografico Militare, over 600 quadrants for transformations of system and datum with the provision of all technical specifications. Is it possible to implement them in Geographic Calculator?
So here we would be talking, I believe, about the GK2 format grids, and this is something that we have had other requests for. Because they are paid, we have not yet gone down that road, but there are a number of people that want to access these.
Yeah, let's. I think we'll follow up with you on the specifics of these just to make sure we're all talking about the same thing.
If you are talking about the GK2 grid, they are ASCII files, so they can be reformatted into a form that we have existing methods to read, but it's a custom system. It's not the official released version from the Italian government.
So sometimes those get a little bit of confusion depending on whose proprietary information and what exact standards you have to follow. Let's see here. Someone's looking for a sample of the format for batch conversions like this session. I would steer you towards our the intro training that we have. So if you go to training.bluemarblegeo.com, we have some introductory data there that is example. But one note on that is all of the things that we have in our training are there's nothing special about them. They just happen to be in whatever order the columns are, and there's much more freedom than what we walk through in our training. Any of the column orders and things like that, you control yourself. So if you do step through the training data, don't feel like it is rigid and all the data has to match when you're doing your own data. But check out the intro calculator course on training.bluemarblegeo.com would be a good place to start. And Scott, a minute ago when you were stepping through some of the batch stuff with the coordinate systems, there were a whole lot of blue coordinate systems in the projections folder. We've had a couple of questions about what people were seeing right at that moment. And this is something a little bit special. So all of these are in blue, and you'll notice under the little icons listings on the left there's nothing next to them. There's no padlock icon that you would typically see of coordinate systems that we ship in the calculator out of the box. So if you notice, the scroll bar on this window is very, very long. Scott, if you just want to kind of wing down through that list, we can show folks just how many things are in this folder. So these all exist at the very top level of my folder. And what we're looking at are 967 new coordinate systems that will be coming along to Calculator possibly next year. These are examples of the new state plane coordinate system for the US, sometimes referred to as SPCS or just simply state plane. So next year, hopefully, if the NGS completes their current schedule, we're going to be adding 967 new coordinate systems all at once. And so what we're seeing here on screen are our testing process, basically. So there is a variety of coordinate systems that are in my database because I just have this locally on the machine here for testing. You'll see a variety of US state names. There's stuff in here for all 50 states, and there's various levels underneath that, whether it's whole statewide coverage or sometimes very small county level coverage, and then zones that are a little more typical of our current state plane type scale. When the new state plane coordinate systems come out, they will all be based on the new NatRef or North American Terrestrial Reference Frame of 2022. Rather than NAT83. Some folks might be noticing that these are all on NAT83. That's simply for testing the import of the parameters at this point. But folks have occasionally asked us about these here. We are working on these right now. All of the coordinate systems that we have here, you'll see are tagged prelim. We've been working with the NGS to sort of make sure all the parameters that are preliminary that they're testing are compatible with Calculator. And so far we have nothing but good things to report. Everything has been very simple for us to bring into our database. And we're looking forward to including these next year when the full state plane coordinate system is actually released. There is going to be this actually ties into the GeoTalks conference that's coming up in January that we mentioned earlier. One of the speakers will be Michael Dennis of the National Geodetic Survey, the NGS, and Michael Dennis is the man in charge of the state plane modernization process. So he's overseeing all of the parameters that are going into all of these systems. So it's really kind of an exciting time to be in geodetics for us here in the US. Should be a pretty interesting talk to hear Michael speak about the what they're calling the alpha release of all of these parameters. But that's what we're seeing here on screen in blue. And then there were a couple of related questions that I thought we'd save and talk about all at once. If you want to maybe go down under the vertical sections in. Actually, sorry, we're in coordinate systems. Let's take a look at the transformations list. There were a couple questions that came in the vertical transformations. Maybe just do the subfolders view. Yeah. So earlier on, there were a couple folks. I'll always ask about this. There are a few entries that we have in the lists in various places, and you'll see these in the vertical transformations, and you'll also see these in the horizontal coordinate transformations. Some of the items in the list are showing in red, and you'll see a little exclamation point icon along next to those. So these are These are all transformations or operations that depend on having supplemental files. And earlier on, when Scott was taking a look at the new Canadian methods and the new New Zealand methods, some of those were showing in a mixture of red and blue. And basically the simple version of this is if they're showing up in red, they are not available for use because you don't have those files on your machine. And all you have to do to download those is you just grab any single one of those. You can multi-select, just like multi-selecting folders if you hold the control key on your keyboard or the shift key if you want to grab a whole swath of them that are all together. You can just simply right-click on those in there and you'll see an option lit up to download the missing files. When you do that, it will reach out to our web server, our cloud storage for these, and pull them down if they are available. Many of these are available, and there are some that are simply not. And the ones that are not get into some of the grids are either fee paid to their publisher, so whatever their survey authority is, or some of them are proprietary in other ways. And so we don't have the rights to distribute those, but anything that is freely available on our site is just a fairly quick download. Some of these are pretty large, so if you are not on a broadband connection, it can take a little longer than it just did on screen as we ran through these. And then one last little note as we were talking about the Canadian method. Their question came in about the difference between CSRS and NSRS, and I have a feeling that probably came from an American who was not familiar with the CSRS notation. The CSRS that we see on some of those, and you'll see this notation on the various NAD83 systems. So you'll see CSRS, and you'll see a couple other things like CGQ77, for example. The CSRS stands for Canadian Spatial Reference System. It is unique to Canada. For those of you that are familiar with NSRS, stands for National Spatial Reference System, and that's the official names for some of those entities in the US. So it's basically the Canadian counterparts to the same NAD83 models that we use here in the States. They just have their own realizations. So if you're in the States, you probably don't want to be using CSRS unless you're mapping north of the border. And likewise in Canada, if you are working in Canada, you don't want to be using NSRS because that is the American version of those. Those are all developed in sort of in partnership between Land Information Canada, Natural Resources Canada. We're talking about New Zealand, that's the Land Information New Zealand. Not that one. Natural Resources Canada, also known as NRCan, works in partnership with NGS on all of these models. They have some similar naming here and there, but they are for north and south of the border.
All right, thanks for those clarifications and additional information, Sam.
Okay, I think we have hit most of the questions that have come in here. If you do happen to think of a late question that you'd like to follow up with us, feel free to send those in to geohelp@bluemarblegeo.com, and we can follow up with you there. Earlier, Scott mentioned a couple other addresses. If you have any order questions about whether you're eligible for the service pack upgrade here, you can send those into orders@bluemarblegeo.com. And we can follow up with those at a later time.
Well, thanks for joining me today, Sam, and thanks for everyone for attending.